Hey guys, so for those of you at home, all right, if you were with me for the pre-lab, you know what you should be doing. And the idea is that I want you to predict using your note card what's going to happen in each of the reactions. All right. Once you have them predicted, you're then going to watch the video, right, to see what happens when we do those. And each reaction should offer some sign of a chemical change for the reaction, whether it's the evolution of heat, the evolution of light, production of a gas, bubbles, formation of a precipitate, a solid coming from two liquids, or a color change. Okay. All right. Now, if you guys weren't in the pre-lab, right, what I want you to do is open up the reactions lab. All right, I'm going to talk everybody through it real quick. Those of you that were here for the pre-lab, just solve a couple right now while I'm talking them through it. Right? But it's pretty straightforward. What you're going to do is open up the reactions lab. All right, just talking about the different types of reactions we have. We have synthesis, we have decomp, single replacement, double replacement, combustion reactions. So what you want to do is go through each of these. So you look at reaction 1 here and see I've got copper 2 sulfate plus zinc. I can do the first one in terms of helping you identify type. I'm not giving you a formula, so you know it's not a combustion. Right. Then I look to see what I'm working with. Copper 2 sulfates, 2 words, so it's a compound. Zinc, 1 word, so it's an element. Anytime we have an element plus a compound, we'd go through our checklist and say, is it a synthesis? No, synthesis is element plus an element. Is it a decomp? Decomp has no plus sign. Nope, can't be a decomp. I see a plus sign right here. Is it a single replacement? Yes, zinc is an element, copper 2 sulfate's a compound. So you guys would list over here somewhere, single replacement. Right. Then what we do is we find like charges and trade. The zinc is going to try to trade places with the copper. And I've told all the people in the pre-lab, you can assume all these reactions occur. That's why I'm having you test them. So you would check the activity series, but I promise zinc is higher up on the activity series than the copper is. So you'd predict your products, which would be zinc sulfate plus copper. And then you'd write and balance it like we always do. Go through 1 word. Is it a Hober-Finkel symbol or the symbol with a 2? 2 words, prefixes, no, symbols and charges and cross. So then we write and balance it. What I want you guys to do is go through each of those. Right? Then, based on what you know about substances, what do I know about zinc? What do I know about copper 2 sulfate? What do you think should happen? And this is just your best guess. All right. What do you think is going to happen when we mix them together? All right. Then we're going to conduct the experiment and you'll make your observations based on what I'm going to show you in the back. All right. You do that for reaction 2, predict it, write it, balance it. What do you think is going to happen? 3, predict it, write it, balance it. What do you think is going to happen? 4, 2 reactions in number 4. All right. 4A is the magnesium plus the oxygen. Right? Predict what you think will happen for 4A. 4B is the magnesium oxide plus the water. All right. What do you think will happen there? And then lastly, 5, the zinc plus the hydrochloric acid. Friendly reminder there, hydroic acids used to be IBE enders. So hydrochloric acid used to be hydrogen chloride. So you do all your predictions. Then you're going to go back. You're going to watch me conduct the experiment. You're going to make observations. Don't make conclusions here. Make observations. Okay? You would say, oh, the substance changed from red to yellow. The substance changed from clear to orange. That's an observation. Right? Don't say, I know a reaction occurred because a color change had happened. Right? Don't say, I evolved a gas. That's a conclusion. You would observe bubbles were forming. Right? Don't say that I had the formation of a precipitate. You would make an observation. Hey, there's solid, white solid on the bottom of the container. All right, so that's what's going on with your observations. All right, now I'll help you with those as I conduct the experiment. Once you get done with all of those, here is where your post lab, you're going to list for each of the reaction the sign of a chemical change. Did we form a precipitate? Did we evolve a gas? Did we have a color change? Did we evolve heat? Did we evolve light? Okay. All right. So what I'm going to do is take you guys to the back and then conduct these experiments. So I'll stop presenting, otherwise things end up backwards. Okay, grab a pair of goggles. All right, and if I give you guys like a quick look at what's happening, right, in the middle counter of the back, all right, I just have a row of supplies with a reaction listed next to it. All right, and the idea there is I come to this location to get the materials I need, and then I conduct my experiment over at my lab. All right, so I'll disappear from you here and there. All right, but I'll always be back. So I'm going to the middle counter to get some things. All right, first thing I'm going to do is I'm going to go turn the gas on because one of our experiments makes us use our Bunsen burner. I'll be back. All right, now in the first experiment, right, what we're going to do is we're going to react zinc with copper to nitrate. And to do that, right, we're going to use just our test tubes and the supplies for the middle counter. So I'm going to take my test tube out. I'm going to take out a test tube, put that in the top shelf. Just turning this so that you guys get a good look at what's going on in there. All right, I'm going to go to the middle counter. Substances I need. All right, here's my zinc. Here's my copper 2 sulfate. All right, the zinc you would find is just a metal. Perfectly okay to touch with your hand. A little bit of gray tint to it just because when the air reacts with it, it gives it a little coating that's zinc oxide and oxidizes it. But no big deal. So I'm going to take that and drop a piece of it or two down into my test tube. All right, then what I'm going to do is take a pipette of my copper 2 sulfate, add that in. Now, I always have you guys do this one first because it takes the longest, right? So we're going to come observe that guy after we run all the other reactions. So that guy's going, but we can't observe him until the end. What I'm going to do is take you into experiment number 2. I'm just going to move these so you guys can get a good look. In experiment 2, I'm taking lead 2 nitrate, which is a clear colorless liquid, and reacting it with the potassium iodide, another clear colorless liquid. All right, so we're going to take a pipette of the first one, squirt it down in there. Take a pipette of the second one, and then I'm going to add it to it. All right, so I'm going to hold that guy nice and close so you can see what's going on. And if you take a look, right, what you're seeing here is a yellow solid. All right, so you see how it can look all grainy. All right, we have a yellow solid there. All right, so I'm going to put that up there. All right, so in your observation section for reaction number 2, you're going to want to go ahead and list, all right, we formed a yellow solid, right, as a part of that, and there's still a clear colorless liquid in there. All right, so that was reaction 2. Reaction number 3. involves the calcium carbonate. All right, so I have a big jug, calcium carbonate here, and I'm bringing over just a wood splint. And what I'm going to do is I'm going to take down my ring stand, and I'm going to take off the iron ring, and instead I'm going to put on test tube clamp, because what I want to do is hold a test tube here above a Bunsen burner. All right, so what I'm going to do is take a scoop of my calcium carbonate using my scoopula. Okay, it's just a white powder. Okay, but I'm going to insert as much of that in there as we can get. Trying not to make a mess. All right, you can see I've got some white powder just down there on the bottom, about a knuckleful. All right, then I'm going to put that inside this guy. Loosen it up just a bit and tighten it back. All right, and what I'm going to do is I'm going to simply heat this thing. Right, heat this guy with my Bunsen burner. All right, so I'm going to go in my drawer. Take out my Bunsen burner. Hook it up to my valve. Set this back just a little bit so you guys can see what's going on. All right, you see right there. Try to take some things out of the back so you have a better look. Go. All right, I'm going to light my burner, right, and I'm going to heat this thing for 5 minutes. Okay, my burner's going. All right, we're going to heat that guy, and you want to keep an eye on it because every once in a while, right, if you produce a gas, for instance, underneath that solid and it can't escape, it's going to want to push that solid up out. So we want to make sure that that doesn't happen. So I'm going to take a look at the clock right now when I'm doing the experiment. I've got it at 4:38. So at 4:43, right, I am going to test this guy, right? Because sometimes reactions take some time to occur. In the meantime, I'm going to take a little peek at our first reaction. And I'm going to let that keep going just a little bit more so you guys can get a good look, right, about what's happening. All right, now one thing I'll do while we're waiting for this is we're about 2 minutes in. I'm going to show you what I'm going to do. I'm going to take this wooden coffee stirrer and use my Bunsen burner to light it on fire. All right, now, if I just hold this thing here, right, he's just going to keep burning, right, because it has the two things, right, that all reactions would need right? If they were going to keep burning for a combustion, right? I've got a hydrocarbon, which is the wooden stick fiber, right? A lot of carbons, a lot of hydrogens in that. And there's a lot of oxygen in the air around us. Hence, this guy continues to burn. So what I'm going to do, right, is I'm going to light that splint and let it be on fire, and I'm going to hold it down inside, right, of our test tube when the time comes. All right, so in the meantime, I'm going to run some water on this guy. Okay, then I'm going to throw him in the trash can. And it looks like we've got about another 2 minutes to go. All right, while that's going on, I'm going to go ahead and set up experiment number 4. One more minute to go. All right, so there's our 5 minutes. Now I'm going to let it keep burning, but what I'm going to do is going to light my wooden splint, and I'm going to insert it into this without touching the bottom. Again, do this a couple times. On fire, and it extinguished. On fire, and it extinguished. So your observation is that it keeps extinguishing the lit splint. I know that's nothing exciting, but there's a good reason for that. If you take a look at the products, right, of reaction 3, right, hopefully you're going to see that carbon dioxide is getting produced, and hopefully you know that carbon dioxide gobbles up oxygen and it won't let the fire keep burning. So it's a confirmation that we think the reaction that we predicted is what's happening. I just detected one of my 2 products. All right, now that's going to be a little bit hot to tear down, so I'm just going to move them to the other side of the counter. All right, let that cool off, and we'll tear that down at the end of the experiment. All right, into experiment number 4. All right, so in experiment number 4, we have to do a couple things. One thing we have to do is take the pH of a small amount of water. So in the middle counter, there's a little piece of hydrion paper where you can tear a piece off, dip it in. Okay. All right. And look at it. And you check out the color and compare it to the color chart on this. All right. So if you take a look, and I'm sliding and sliding and sliding, you're going to see that we're right over here in this like sort of greenish orangish, which puts us in the pH range of like 6. All right. Somewhere between 5, 6, or 7. All right, for the plain old fashioned water. All right, now we need to do that because what we're going to do is we're going to take the products from experiment 4A and we're going to dissolve it in this. So right now, what I'm going to do is conduct experiment 4A. And what you see here is some magnesium ribbon. Right, so with this magnesium ribbon, I am just going to cut a little piece off with a pair of scissors. Then I'm going to go in my drawer, grab myself some beaker tongs. And then what I'm going to do is I'm going to light this on fire to let it react with the oxygen in the air, which is 4A. Right? We're going to let the magnesium react with oxygen in the air. And then what I'm going to do is I'm going to try to catch the ashes inside this little beaker that has some water. All right, so I'm going to start my burner up again. Going to get my magnesium ribbon. And the observation for this will be very easy for you to see once it starts. I'm going to turn away because we should never look at something that bright. And then using my peripheral vision, once all that bright light goes away, all right, I know I can look at this. All right, now, so what I'm doing is I took those ashes and I got them inside of my little tiny beaker here. And what I'm going to do is I'm going to get those guys to dissolve. Okay, I'm going to try to get the ashes off the edge of my beaker tongs as much as I can. All right, but we have plenty of ashes in there. So off my beaker tongs. They're good to go. Put those back right in my drawer. I'm just going to go get my stir bar. All right, and really try to break this up and get it to dissolve. Right, and what I'm doing right now is reaction 4B. All right, the ash, which you guys hopefully have figured out is the magnesium oxide, is now reacting with the water. All right, so it looks like we have that dissolved. And now what I'm going to do is I'm going to take another piece of my hydrogen paper and I am going to dip it inside of that substance. This time, if I hold that up for you to see, right, and I hold up my chart, if you can start scanning, you can see I am way up here in the 8, maybe even the 9 range for my pH. So there's your observation. All right. Your first observation for 4B was the pH of 6, 5, 7, however close you thought it was. And then your second observation is now that the pH became 8. Okay, maybe even 9. All right, so there's experiment number 4A and 4B. All right, last but not least, we need to do experiment 5, and we need to observe our experiment 1. All right, so bring over my materials for experiment 5. Bring back my test tube rack. Grab myself a new test tube. All right, and what we're doing in this experiment is we're taking hydrochloric acid and we're going to react it with another piece of that zinc, all right, to see what happens if we put the acid with the metal. So over here, I took the metal and I put it with a compound, copper 2 sulfate. Right? What is it going to do if we put it with an acid? So I'm going to drop this guy in here. And then I'm going to take a pipette of my hydrochloric acid. And we're going to inject it. Like I said, we're going to give it a second to get going. But if you take a look, sure enough, is you're seeing a whole lot of bubbles, right, forming on that metal. Right, so lots of bubbles, right, coming off the surface of that metal, and you're seeing them gradually make their way up to the top of the tube. All right, now let that go, and I'll show it to you again. Sometimes it gets a little more magnified as we keep going. All right, but the last thing we need to do is make our observations on our first test tube. Now, you can still see we have the blue clear liquid in it. Clear because you can see through it, right? You can see my arm behind it, all right, but still blue. What we're going to do is dump off that blue and see what the metal looks like now. So there's the blue. Get a pair of tweezers. Right? If you remember, when we started that, it was a silver piece of metal. Right? Remember that grayish? And you can go back in the video and take a look if you're not sure. Right? But here it is now. And you can see it is definitely taken, all right, a change here. All right, so I would describe this as a pinkish solid that is now on the surface of my metal, and there's the other piece that was in there. All right, so your observation there would be pink solid formed on the metal. All right, and then one more look at reaction 5. You take a look there. Right, you can see tons and tons of bubbles, all right, sitting right on that piece of metal. All right, so you have all the tools you need to make your observations. You guys can now jump into the post lab, make your conclusions. All right, I'll be in cleanup land, which, although it is important, it is not video worthy. All right, and if you guys have any questions, please just jump into the Meet Ask, and we will get you guys squared away. All right, hope to see you guys back soon.